Hi, my name is Emanuel Markoulakis. I'm here a PhD candidate in the Hellenic Mediterranean University, and I'm about to present you a new, for what we believe is a revolutionary, groundbreaking research in particle physics, and namely a hard spin fiber model for the electron, which is published in the in the National Journal of Physical Research. It was published this year, January of 2022. What this research deals with is the charge of the electron, not its interaction fields with the environment, its B magnetic field, intrinsic magnetic field, and E electric field, but actually what is this charge? What is its specific flux, and how it generates all its intrinsic properties, like the charge value we measure with great accuracy, its magnetic moment, which is one of the best measured, more accurate measured values in quantum mechanics, with more than 24 digits, decimal digits accuracy, and how it generates its angular momentum, and what is its chirality, what is the origin, the physical origin of the chirality, what is the fine structure constant, from where it comes, how it comes to be, this value, it's 1 over 137 value, which is one of the most important constants in nature. So our model explains this by not adopting the known standard model view of the elementary electron particle, which says that this is a dimensionless point massive particle. So we explore actually the intrinsic mechanics of the particle by giving it volume, a specific geometry, and a manifold, a flux manifold. It's a flux of the energy flow. By doing that, this gives us some very big advantages, that now we can describe the charge of the electron, which we will later see that it is the electron. The charge is, there is nothing else that's charge. Charge confines everything: magnetic moment, electric charge, the mass, everything is just a flux of electromagnetic flow, electromagnetic, and a manifold of electromagnetic flux. So the standard model view is that the electron is a dimensionless point massive particle, which brings many problems. It's also called the bare model, the bare mass model of the electron, where the electron is demoted, we can say, to just a point, a mathematical point without dimensions, and that gives growth of infinities, and then later on they must use renormalization to get rid of these infinities. So we don't have, our model has not these problems. By giving it geometry, specific geometry and topology, we were able to extrapolate with our model all its values, all its known in the literature values, like charge, spin angular momentum, its quantum spin, its spin magnetic dipole moment, its mass, and so on. And also the physical origin of for the first time, what is the physical origin of the fine structure constant, which is a property embedded inside this flux manifold we described of the charge of the electron. And it's actually, we found out it is a geometrical proportionality constant of this geometry of the charge of the electron. So we know that the total angular momentum of the electron is a square, the square cube divided by 2, which is approximately 0.866 the reduced Planck constant. In classical mechanics, you can have angular momentum without any rotation. So there's a conflict in the theory, the accepted theory, that how can something which is regarded by the standard model as a dimensionless point, which can by definition have not spin or classical rotation, can have an angular momentum, which we measure in the lab. This angular momentum here for 0.866 times the reduced h bar. Yeah? So the problem is that because the Heisenberg uncertainty principle, we're not allowed to give any dimensions to the electron, which is considered very small. But they never actually measured the actual size. So the resolution the standard model gives to this problem, to this conflict, is that the electron is a dimensionless point, massive particle, and has no size. Therefore, it cannot physically spin and has an intrinsic quantum spin and not a classical spin. So what the standard model actually admits with this statement is that they don't know what the intrinsic mechanics of the electron are. So there are some kind, not hidden variables, but we cannot see these intrinsic mechanics. We cannot ever know the mechanics of this of the electron. There's this intrinsic internal mechanics. But this is not good enough for a scientist very curious like me. I want to know exactly what this dimensionless point is doing, what its intrinsic mechanics are, and how it generates all these values, like the charge value, the spin angular momentum, the magnetic moment, and so on. So this was the motive of doing starting doing this research. So here you see the author's remarks, that the author finds the given solution not satisfactory. By intrinsic, the standard model actually admits that these properties and the non-measured values, they don't know how they came to be. So a complementary submodel beyond the standard model theory must be developed to investigate all these intrinsic mechanics. And some very important point here at the end, since the intrinsic physical property values of the electron at rest are constant, this can mean only one thing. So every time we measure this, the charge value, the mass, the magnetic moment, these are very accurate figures. So this can mean, this strongly infers that the internal mechanics of the electron must work like clockwork. So they are actually deterministic. So if they are deterministic, the model which must be developed must be semi-classical, which is something logical. If you measure these values always with great accuracy, even at the accuracy of the 24th decimal point, we're talking now this kind of level of accuracy, that can only mean that the intrinsic mechanics of the electron are actually classical and deterministic. They're not probabilistic. So the electron, its intrinsic mechanics are working like clockwork. So here are some research highlights and the significance and novelty of this paper. We say, from physical quantum emulation observations, mathematical analysis, and Wolfram alpha parametric polar simulations, and mathematical 4D animations, we calculated a fiber model for the dressed bare mass electromagnetic field of the electron. It's actually a fancy way to say the charge of the electron. And with that, we could extrapolate all of its known properties like charge, angular momentum, magnetic dipole moment, handedness, and etc., etc. Therefore, our model is an intrinsic mechanic model of the electron at rest and shows the possibility that the elementary electron, although it has no inner subparticles, it can possess a specific energy flux manifold. So now the charge in our model, in our fiber model, is not described like a point charge, a dimensionless point charge, but it has actually a radius, the charge, and has a specific morphology we will investigate later on in this presentation. So some research highlights: novel fiber model for the electron at rest, calculating all of its intrinsic properties. Secondly, fiber model shows the possibility of electron having intrinsic mechanics in the form of a specific energy flux manifold. Third, electron described, this is also an interesting point, as a half spin dynamic topology twisted photon. So we see what you will see later on in the presentation, what the topology of a normal photon is, and how this topology, if we twist the energy flux, it results to the electron. Normally, this is true. All photons have spin 1. But imagine a deformed photon, which does not travel only linear in space. It does not translate only in space, but also spins around an axis very fast at the speed of light. Its tangential speed is at the speed of light of this twisted spinning photon, and this gives rise to what we call the electron particle. These are all mathematically verified, analytically verified, and also simulated with Wolfram alpha. So the unified electromagnetic flux field manifold of the electron at rest, which is what we call the charge, the charge of the electron, is shown, and the origin of the fine subtraction constant as a proportionality constant of the electron topology. This is very interesting. It's done for the first time, and this will present it at the end of the presentation, and it's a very important contribution of our research. Model was extrapolated by physical quantum emulation, analytically verified, and also algorithmically using Wolfram alpha parametric polar simulations. So let's now dive in. Here is the classical view of the electron as a dimensionless point. So this has not even this size, it's dimensionless, which has intrinsic mysterious mechanics. You can say that this expression, and that these mechanics are generating all these properties: its charge, magnetic moment, its mass, etc., etc. But no one knows exactly how these properties came to be, and why are these exact values of these properties are measured. So here we have an inflated, to make it more visible, an inflated electron. This point now is inflated to a sphere, so that to make it more visible. But again, I say it's a dimensionless point. That is the standard view of the standard model, the accepted theory. So, and this here yellow region is the charge. We have, however, to discriminate between the charge and its influential fields, its interaction fields. So the charge of the electron generates two fields. Many know that it generates maybe only the electrical field, which is represented by this vector here, this vector field. Because the charge is negative, the vectors of the electric fields are going inwards. But this is only the half true. The electron has also a spin, an intrinsic spin magnetic dipole moment. It's actually behaves, we can say, very close enough as a small bar magnet, and has also this a magnetic dipole field. The blue lines are the magnetic field, and the gray arrows are the electric fields. But be careful. This is not the charge. These two are the interaction fields of the electron charge with the environment, with its environment, with whatever is around it, other particles or whatever. Yeah. So our study does not concentrate on the interaction fields here, electric and magnetic. It concentrates on this yellow ball here, in this yellow sphere. What is this? What is the charge? This is unknown until today. We say charge, a point charge, a point in space without dimensions, which generates magnetic electric fields, magnetic moment, mass, and so on, etc., and etc. So now we concentrate. Our model suggests what exactly is the energy flux, a specific manifold of energy flux, which describes this yellow sphere here. And now we're going to the actual outline of our model, which is this specific energy flow. And what is the nice thing here? The charge is not only electrical. It is unified. It combines both the electric charge and the magnetic dipole charge. It combines, so its electrical charge, which generates its electric field outside to the environment, and also its magnetic dipole charge, which generates its magnetic moment. Magnetic moment, we say a magnet has a magnetic moment south to north. It's actually the dipole. The magnetic moment describes a magnetic dipole, a magnet, essentially. So we see here the flux lines. These are the charge flux lines. We have this specific manifold. It's actually like a dipole vortex. You have two vortices, two opposite vortices, back to back, and they are connected with this here vortex tube, or called vortex string. So here this flux here going inside this horn tube formation, represents the magnetic moment of the electron charge, and all the other flux lines in the perimeter on the surface of the sphere, of this horn torus, horn spheroid, that's the geometry that is called horn spheroid, is the electric charge. So you have the electric charge of the electron, which is all the flux lines on the perimeter, and the lines going inward in this tunnel here represents its magnetic dipole charge, its magnetism, which is actually nothing different if you see the magnetic field in a magnet or in a electrical coil, so an electrical solenoid. It's actually similar, the fields. Only here the flux has this specific diagonal manifold. We will explain why is this. Yes, it couldn't be any other way actually, because if you have two vortices and you have them connected, essentially the lines will form spirals going from one pole to the other, and recycling back from one pole to the other. Okay. So this here is the famous Einstein equation, mc square, which exactly what it says, that if you have a flux, an energy which is confined in a space, then you have a mass. Confined energy in a specific volume of space-time creates a mass. Of course, our model does not exclude also the interaction with the Higgs field, but this is another chapter. So, and the angular momentum is, if you use the parallel access theorem, is the mass of the electron times its tangential velocity, which is here the speed of light everywhere, the tangential velocity, times its radius, the charge radius. This here is the charge radius. So our model is called a dressed model. It's not the bare mass model where the electron is a dimensionless point massive particle, but this actually has it's dressed. It has a charge. The charge occupies a volume in space. This here, this simple giving volume and specific geometry and topology to the electron, you will see later on, gives answer to almost all the mysteries and unknowns we have until today. It's a bold move, but it is, you will see it pays off. It pays off. So our model, mass, charge, and magnetic moment of the electron are unified under a single electromagnetic flux manifold. Yeah. So what is this the meaning? What do you think these lines here are? The lines here. What can it be? It's a charge. Okay, we know the fields, they have electric flux lines, and if it's a magnetic field, it has magnetic flux lines. But what are the flux lines in the charge of the electron, of this yellow here region? What kind of flux is that? What do you think is the flux? It cannot be anything else than electromagnetic flux, unified electromagnetic flux. So these are not now electrical or magnetic flux lines. These are unified, it's a unified electromagnetic flux. When, if you think of, and maybe this is not very obvious to many, is an electric flux line compared to a magnetic flux line has no different at all except the curl. In the electric flux lines, these are straight arrows, but the magnetic flux lines are curling in, making the dipole field. So the flux lines in the electric field has zero curl, but in the magnetic has non-zero curl. That's the only difference. Yeah. The flux lines consist from virtual photons. It's either the magnetic flux line or the electric flux line. It's made up from the same stuff, namely virtual photons. So there's no other difference, only the curl, depending the source of the distortion. So what our model says is that actually there could not be any other way. You know that in the electrical and phenomena and magnetic phenomena are interchangeable, are interconnected, are somehow embedded. So the mass also, the charge of the electron, the total charge, must be also unified, must be a unified charge, so that the electrical phenomena are interchangeable with the magnetic phenomena, which are both caused from the source we call electron. So there is no difference between the electric and magnetic flux. The charge has a unified electromagnetic flux, and mass, charge, and magnetic moment of the electron unified under a single electromagnetic flux manifold. So here you see the manifold, the unified, and you have the magnetic moment under this manifold here, this specific flow of energy, of electromagnetic flux. You have embedded the magnetic moment of the electron and the electric field, the electric charge. So you have magnetic dipole charge, this conformation, and electric charge, which is the surface of the electromagnetosphere of the electron, what we call charge of the electron. So it explains classically the quantum spin of the electron. So in our model, the electron actually spins, physically spins, which is not accepted in the standard model because it's a dimensionless point and cannot spin. There were measurements done, and they have put an upper limit in the scale, in the level of 10 at 18 power minus 18 meters, 10 minus 18 meters, minus 18 power of 10 meters, an upper limit in the size. They didn't actually find any size because it's very difficult to find the charge radius here. You cannot distinguish where the interaction fields, the electrical and magnetic dipole field stops, and where the charge here, the yellow sphere, starts. So they cannot define the actual size. And their main argument is because it's very small, it cannot spin, because then it will break the speed of light. But we will, in our model, prove that the charge radius is not that small as it's believed to be, and therefore it can spin with tangential speed here, the speed of light. So, and also because the Einstein equation, it's also this charge here, this morphology here, this topology of charge, this specific flux manifold describes, also defines its mass. So where's the electron? Just in front of you. This is the electron. There's no obstacle here inside some solid stuff. This here is the electron. This specific formation of electromagnetic flux is the charge and is the electron. So, and another point very important, we know from actual research by independent researchers, not from our university here, the Hellenic University, but from very respected research which was published in Nature magazine, that the charge of the electron, this here formation, the yellow stuff, must be a sphere, must be spherical. How they measure that? They measured the external interaction field, electrical field, in a sphere region 306 degrees around, spherical. Of course not the charge, but the interaction field, the near interaction field, and they found the charge distribution homogeneous, very homogeneous. So that results that from that we can result that it must be a sphere. The charge must be a sphere, must be spherical. Because if it was say a rectangle or a cylinder, the charge distribution will be not homogeneous. So we know from other research that it must be spherical. So keep that in mind, that the charge experimentally found from other researchers must be spherical. So a manifold or propose here a manifold for the charge for the electron is a sphere, actually, is essentially spherical. So now here we'll go dive in more to our research. Believe it or not, our research is based on experimental data. We have done several publications with a quantum magneto-optic flux viewer, the ferrolens. And the ferrolens has a very little quantum coherence and can see inside the quantum field, the net quantum field of a magnet, which is different from the classical field outside, the classical magnetic dipole field we know. We saw with this device, the ferrolens, the two vortices here, which are imagine this 3D here charge formation, but now it's split in half and laid down in a 2D surface. So these two are the two vortices, which are connected with this here tunnel, this vortex string here. So using this actual, because the magnet, if you can imagine it, the magnetic field of a stationary electron. All the unpaired electrons inside the magnet, the ferromagnetic matter, the permanently magnetized ferromagnetic matter, are allying the magnetic moments, all the electrons, to one direction. So the field of the many, the quantum field of the many, is actually the mirror, the image of the field of the one. And what is the one here? The one is the electromagnetic charge of the electron, because the electron creates electromagnetism and the magnet. So you can see that like stationary, this here, this imprint, this quantum imprint here, you can see that as the stationary image of the charge of the electron. It emulates the stationary image of the electron. This was also published in the results in physics, this research with a ferrolens, which is also very important research, because this leads us to this research here we are presenting today. So here you have a spin down electron. You know, if you have this is in the literature written, the electron, if because it has a negative charge, its magnetic moment, direction south north, that is the direction of the magnetic moment, south pole north pole, is opposite to the spin. The spin you always find out with the right hand rule. You bend your fingers in the direction of rotations. Say for example here, this here, this spin down electron, which rotates clockwise. So your thumb shows down. That's from where we get the description spin down electron. But the magnetic moment always is 180 degrees opposite, in opposite direction. And we can see here the helicity and chirality, the intrinsic chirality of the electron. The electron always to the vertical z-axis, the flux lines are leaning to the left. This gives us the left chirality. And in the positron, which has a positive charge, and is right-handed, has its right chiral, the lines are leaning to the right. Yes? Actually, now will someone say that no, the electron is a combination of left chiral and right chiral electrons. This is only a mathematical concept, and I will show you now where this comes from, why physicists say the electron is a combination of left chiral electron and right chiral electron at rest, always at rest. We always demonstrate here, our model is the electron at rest. Yes, examines the electron at rest. So I will show you now from where this comes from. So from where this left, so the standard model says that the electron is a right chiral electron and a left chiral electron, which alternating the chirality. The chirality is alternating. This is because it pumps in the Higgs bosons on the Higgs field. Every time it pumps in one Higgs boson, it alternates chirality from left to right. And this frequency of flipping, constantly flipping between left and right chiral, gives the mass of the electron, which is gained from the Higgs field. So that's the standard view. But our model, but they never explained it physically. Our model is a physical model. It's not an effective model. It's physical. It's actually what it is there in nature. So how our model describes this, all these very nice words, but what is the physical meaning of these words? So here you see our model. This is a spin down electron, and this is a spin up. So now it rotates anti-clockwise. The charge flux, it's rotating anti-clockwise, and therefore the spin is pointing. The spin is pointing up, and the magnetic moment always opposite. Yeah, opposite to the spin vector, because the electron has a negative charge. In the positron, because it has a positive charge, the magnetic vector is always aligned with the spin vector. So again, back to this spiral left chiral and right chiral stuff. If you go now to the polar view, imagine that you are here above and you look down to its north pole. Yeah, that's the magnetic moment. It's the direction of south to north pole, actually. If we click here, we go now to the polar view. So the polar view, you see these faint blue lines, which is the opposite pole, the flux line coming from the opposite pole of the electron manifold. What you see here, this is exactly what they mean. This is the left chiral electron. The lines are leaning to the left. Yes, and on the opposite side, looking see-through. The opposite side looking see-through now, through the model, through this 3D model, you see these blue fader lines, which are opposite chirality. The opposite are right chiral, and the front here, the more blue lines, more contrast blue lines, are the left chiral. That's what they mean. So we see here that if you take here a point here in space, it's alternating between the blue lines and the more faded lines. So it's alternating between left chiral and right chiral electron, and both are in superposition in space. They're overlaid in space. So that's what they mean. They're not two different versions of electrons. It's actually at rest, the electron is one. It's a physical electron. What all these fancy mathematical inventions describe is actually the specific flux manifold, charge flux manifold of the electron. So this in parenthesis, which is not now directly in your study, but I think you have to know this. This is an important physical explanation of what all these concepts mean, which are presented from quantum field theory and the standard model, but they don't have any physical interpretation. Because why? Because if you say that the electron is a dimensionless point without any dimensions or volume or geometry, you cannot describe these things. But our model, giving geometry and volume to the electron, can describe the physical origin of all these concepts, which are not wrong. We don't say that they are wrong, but the physical meaning is missing. The physical meaning, and what is physics without any describing the actual physics, the actual nature of things? So going back to our main presentation now. So here we see the different in different magnetic moments and spins the electron. Here we have the electron spin down. Here we have it spin up, and here is the positron spin up and the positron spin down. Immediately we notice that these are diametrical. There is a correlation here, which actually describes what the charge and what the origin of the chirality is. You see, these are diagonal, these are antisymmetrical. So our model explains also the physical origin of the chirality. The chirality we say here, the electrons actually, the intrinsic chirality is left-handed, because you see the flux lines, the charge flux is leaning to the left here in comparison to the vertical axis. But here, which is actually it characterizes also the charge, because all the right, almost as far as we know, all the positive charge fermions are right chiral in nature. So here in the positron, which is a right chiral particle, the charge flux lines of the manifold are leaning to the right. So this is the physical origin of the chirality of the particles embedded inside their flow of energy, inside the magnetic flux manifold, inside the geometry. This here is a novel equation we have derived, and it explains exactly what the magnetic dipole charge is, not just the charge, the electrical charge which is here on the surface, but the charge which is going inside here. Yeah, it's coming out from the North Pole. You see here, if you follow the flux lines, and then get drawn by the South Pole and then recycled back to the north. So this equation here calculates the magnetic dipole charge flowing inside the Horn tube formation, and it's the electric charge. We don't now. These are absolute values. We don't give signs here. This is the electric charge times the speed of light in the vacuum. This is derived in Appendix 1, and you can find it inside the supplementary material of the published research, which is the reference 2080, if I remember. It's in Google Drive. It's all the appendices, because it's quite large. The paper is quite large. We have put all the appendices and relevant research inside supplementary material, which is inside the Google Drive. the institutional Google Drive. So what the magnetic type of charge in physical units represents is actually square meters of area per second. So it's the type. It's actually what we say here. What this equation here calculates is the charge here on the perimeter, on the surface of the electromagnetosphere, which is flowing per unit of time, the area square meters, which is flowing per unit of time inside the Horn flux here, inside here the Horn cube formation. This here is described by this equation, which is a very important equation later on in our research. So now we will discuss some very interesting point here and the result from our research, in which we say that the electron is actually a twisted half-spin spinning photon. So it's what is topologically a photon? A photon is a normal photon is actually a loop, a perfect circular loop, which the perimeter of the loop equals the wavelength of the photon, which many same frequency photons make monochromatic light. So this is a photon. What our model actually reveals is that the electron is a twisted loop, like this here. It's actually an unknot. For people who are in the field of knots, it's an unknot, and which has a total spin angular momentum of square cube divided by 2. So namely this value here, approximately 0.86, the reduced Planck constant. This is a spin angular. Opposite, a photon has 1 Planck unit spin angular momentum, and it's normal because for the same radius and tangential speed, a loop generates more angular momentum than a twisted version of it, like this. So what is the outstanding, the astonishing part? All this flux here, this charge flux, the charge of the electron is generated just by photon, by one spinning twisted photon, which spins here relativistically at speed, the speed of light in the vacuum, c, and actually not only spins but also revolves. It's revolving. It's like a windmill which is revolving around. This ribbon here revolves, and in the same time also spins. So we can see here the two frequency spin components of the electron here in this animation. So we see here the ribbon is revolving, represented by this yellow here strip. It's revolving with a frequency f revolution, and at the same time is also rotating, and the combined motion is this here. And if you put this in the volume of the charge sphere, you have all this. This is going very fast here, and forming relativistically the final charge of the electron. It's revolving and spinning inside this volume here, which makes up the charge of the electron, the specific flux manifold of the electron. Yeah. So an important characteristic of our research is the Compton wavelength of an electron, which imagine it as the energy equivalent of the electron if it is transformed to a photon. It's the energy equivalent of an electron. The Compton wavelength represents an energy equivalent photon with an electron. So it's actually, if you take this ribbon here, this twisted photon, unfold it back to a perfect circular loop, what is the wavelength? So the perimeter here of all this trajectory gives the Compton wavelength of the electron, which is in the literature, and the reduced Planck constant, this value here, where this is the Planck constant, the mass of the electron and the speed of light. If you divide it by 2 pi, you get a figure. It's called the reduced Compton wavelength, which is actually, if you see, it's the perimeter, where RC is the radius of the equivalent photon energy, of the equivalent energy photon with the electron, divided by 2 pi, which is actually the radius here. The radius, if you get this and unfold it back to a circular loop, what is the radius? This is the reduced Compton wavelength, which is 3.86 times 10 over minus 13 meters. Yeah? This is actually the charge radius of the electron, which is consistent with the speed of light. And in our model, it's a bit shorter. It's not 3.86. We will see later on it's a bit shorter. Because why? Because now this ribbon here is not perfect circle, but it is twisted. Therefore, it occupies a smaller volume in space. Yeah, you see here. You have the ribbon here, this twisted half-spin photon, which is relativistically revolving and spinning and creating the charge of the electron. That's our model is saying, the whole charge. So you have one twist photon, twisting and revolving very fast. We will later on calculate the exact frequencies for the revolution frequency and the spin, because there are two frequencies. The ribbon revolves, which is the F revolution frequency, angular velocity expressed in hertz, and actually it rotates, it spins around its axis, which is the Fs, the spin frequency, the angular velocity of spin rotation, which is also expressed in hertz. So this, because now the ribbon here, the energy ribbon, is twisted, it's not fully extended to a circular loop, it will occupy a smaller volume, and therefore the radius is not exactly 3.86, but it's a bit smaller. We calculate this and verify it with Wolfram alpha simulation later on in this presentation. Yes. Another important characteristic our model explains the physical origin of this characteristic is the 4 pi spin rotation of the electron, which is measured in the lab by others, not by us, with accuracy. It's actually the Dirac belt phenomenon. And what is this Dirac belt? If you have a sphere, if you turn it 36, if you take a point here on the sphere and turn the sphere 360 degrees around, you will get to the same point in space. But this is not what the electron does. The electron returns back to the same state, to the same phase, after 4 pi rotations, after 2 rotations, which is a quantum, they characterize it like a quantum effect, but not really, because our model explains the physical origin of this characteristic of the electron and as follows. If you take here the ribbon of the photon ribbon, a fixed point, and you will say you will reach for the point back in 2 pi spin rotations. But let's see if this really happens here. So you will take here a point, a fixed point, and follow this point. You will see by your own that you will after 2 pi you will end up here, down, which is not the same state. It's a different state. Only after 2 full rotations you will end up here again. You know? Okay? You understand? So our model explains the physical origin of this effect, which is intrinsic to all half-spin fermions, all charge fermions. Yes? Again, if you take a point here and follow, you remember it revolves and also it spins around an axis. So after 2 pi you will end up here, but this is not the same state. It's not the same. But if you make another rotation, 2 pi, 4 pi in total, you end up again on your starting point. So this, our model explains physically also this characteristic, which is not just a Dirac belt. This is the energy flow of the electron, because this can also be demonstrated by the Dirac belt. You just Google, put in YouTube the name, the phrase Dirac belt, and it is described with a Dirac belt, but with a belt, with a normal belt. It's called Dirac belt. But what we are saying, that this is actually the structure. It's a ribbon. It's a photon, an energy ribbon that spins physically and also revolves. There are two frequencies: a revolution frequency, Fs, and a spin frequency, Fr, the revolution, and Fs, the spin. And all this fast revolving and spinning photon, twisted photon, makes up the charge of the electron in this specific manifold. And something else, we have said before that the mass is actually the confined here electromagnetic flux energy, and the center of this topology is also the center of mass. So we'll not totally discard the standard model view that the electron is the mass of the electron is a dimensionless point. Yeah, of course, if you have an energy, a confined energy, and this is a symmetrical confined, then you have always a point at the center you call center of mass. And remember, center of mass is a dimensionless point. So our model combines actually the charge radius, which we're saying that the electron has a finite charge radius in space when it is at rest, and also in the same time it's also a dimensionless point. Yes, the mass is here focused here at the center of the whole tube. Another important characteristic our model physically explains its origin is the magic angle of the geomagnetic rotation of the electron. The term magic angle is not just a term we have invented. It's actually a mathematical description of this figure here, arctan square root of 2. So what they have, it's also stated in the literature, and they have measured it, is that if you put an electron in a homogeneous z-axis field like this here B line is going straight up of an external field, it will geomagnetically rotate its magnetic moment. You remember from the previous picture, the electron has a magnetic spin, physical spin, and also, at least in our book, in our research, it's actually physical spinning. But I mean a spin, magnetic dipole spin, and also it has a magnetic moment. Yes, so it will continuously here rotate around a B line. Around the B line, it will rotate its magnetic moment geometrically around this line. Imagine here a B line of the external field here coming, and it will rotate its magnetic moment, or actually the spin, which is pointing in the other direction here. It will rotate it constantly around this flux line, this external B field flux line. And the ratio, the speed in hertz, the angular velocity by which it is rotating, it's given by the geomagnetic ratio, which is omega angular velocity times gamma, the geomagnetic rotation omega, equals gamma, which is the geomagnetic ratio, times the B field, times the B field. So omega, the geomagnetic rotation, is gamma times the strength of this external B field. So the stronger the field is, the faster this rotation around of the magnetic moment of the electron, the intrinsic magnetic moment. Remember, the electron behaves like a small magnet, dipole magnet, around this external B line, flux line here. But what is the astonishing here is that this rotation forms here a cone. Yes, forms a cone. The surface of the cone relative to the z-axis here, the verticals, is always at an angle of exactly 54.7 degrees, which is called in the literature magic angle. So, and this is fixed. This is fixed. This does not change. You can have only two values, plus 44.7 and minus 44.7, depending on where the cone looks down or up. If it looks up, then we call this a spin up electron. If it looks down, then it's called a spin down. And the total spin of the electron, which is 0.866 times the reduced Planck constant, has two components. In the z-axis, can analyze in the z-axis, which is it has a value of spin angular momentum half the Planck constant, and is exactly from where the electron gets the name spin half fermion. And we will see later on, because we are not constrained, our model is classical, we're now examining the intrinsic mechanics inside of the electron, so we are not constrained by the Heisenberg uncertainty principle. We see on the z-axis, if we project the horizontal axis component, is 0.707 h Planck h bar, yes, which is actually the reciprocal of square root of 2. So this is how the flux manifold, the charge flux manifold of the electron looks like if you put it under a homogeneous external B field running on the z-axis, the B field. Its spin is declined by an angle of 44.7 degrees relative to the z-axis here, and here is its specific spin rotation. So this specifically here electron is spinning anti-clockwise. So if you put always the spin, you get it with the right hand rule. If you twist your fingers to the direction of rotation, then the thumb will show you the spin. So there is a spin up electron, and the magnetic moment is pointing down in the opposite direction here. Here is the spin, and here is the magnetic moment. And the magic angle relative to the z-axis here, which is always 44.7 degrees, and it's independent the strength of the field. So whatever the strength is, this angle is always fixed. It can be, it has only two values, plus 45.7 or minus 45.7 if it looks down, if it's a spin down the electron. Yes, this is a very important point. So only the geomagnetic rotation rate changes, the speed by this wobbles, yes, but not the angle, not this magic angle. This is very important, and this actually, one of the implications of our research is the reason why we have the quantization of spin in space, which is also demonstrated by the Stern-Gerlach experiment, because exactly this magic angle, it has a binary value. It can be only plus 44 or minus 44, and this gives exactly, this is the physical reason why we have the quantization of spin in space of the electron. Yes, of the spin magnetic dipole moment of the electron. And this also is very well explained now with our physical model of the charge of the electron. So now we are going to the more technical details of our model. We calculate here the effective angular momentum of these two rotations Fs around an axis of the manifold, and the revolution of the ribbon, the effective revolution, if the revolution was a circular loop. With the red here, there is no problem, because actually the spin is a perfect circle, the spin around the axis of the whole electromagnetosphere of the whole charge, with tangential speed c, and the radius we have to calculate the exact radius. And the problem here is here in the revolution, because the trajectory is not a circular loop. So we have later on to calculate the exact figures using Wolfram alpha, inputting the exact parameters. So then we can calculate the expected spin angular momentum value for the non-circular revolution. Because remember, it's a twisted ribbon. So here, this is only, we calculate here an effective value, but it's not the actual value. The actual value is calculated later on using Wolfram alpha simulation. So we have now here the three vectors of the complex rotation of the charge. We have its value in the z-axis, the spin angular momentum, which is half h bar. We have the magic angle, which is fixed, and we have the value here, which is known in the literature, of the total spin angular momentum of the electron, which is 0.866 h bar. So now, with using Pythagorean, we can calculate the projection component on the x-axis, which is actually the revolution component of the total complex charge spin manifold of the electron, and which is the reciprocal of square root of 2. So the LR, the revolution generated spin angular momentum, has a value of 0.707 h bar. Again, we are not constrained by the uncertainty principle, which tells you that you cannot do that. You can examine always in one axis the spin angular momentum, but because our model is classical and we're now looking inside the intrinsic mechanics of the electron, where quantum has no reach anymore, quantum field theory, we can actually calculate its two components of this complex revolution and spin rotation the charge flux has. So using all these equations, we have two criteria in order our model to be consistent. The angular momentum criteria, which is this equation here, the ratio of LR over LS must be square root of 2, and actually this analogy equation here, which is this is the criterion so that our manifold or proposed model does not exceed the speed of light. Is at the speed of light, yes, and does not exceed the speed of light, and it's exactly c, because you see here that the tangential speed is c. So using the equation of angular frequency, where v is the tangential speed, this c, it's angular velocity over the radius here. So we calculated also that in order all this to hold, Rs, here this radius times s, a parameter we define, must be the value of Rr here, the radius of this revolution here. And the parameter s is exactly this angular frequencies of rotation, Fs over Fr. Yes, the ratio of these two frequencies of spin and revolution is the parameter s. And this is actually the beauty of our model, because using this magic angle, the total spin angular momentum of the electron, and these two frequencies of rotations, these three components describe the whole manifold, the whole complex charge flow of energy of the electron, of this single photon, twisted photon. The whole trajectory, the whole electromagnetosphere, the whole charge can be described with these three parameters: the magic angle, the total angular momentum of the electron, and this the ratio of these two frequencies. If these are all obeyed, then the model, the flux model we propose, which is now parameterized, will describe everything. It will generate the magnetic moment of the electron, the spin angular momentum, the charge of the electron, the magnetic dipole moment, and also the helicity we have observed, and so on. Something very important we have omitted previously. So what we omitted previously, which is very important, we didn't say how this magic angle came to be. What is the physical explanation which our model gives, of course. So I think it's obvious, it's already obvious how this magic angle is here generated, this relative to the z-axis here, why this angle here is always 44.7. If you look closely, the charge flux which is passing here the equator as the whole energy flows is relative to the z-axis at exact angle 44.7 degrees. So the flux charge, the leaning of the flux charge here, the spiral trajectory with this exact angling of the energy flux lines passing from the equator, is exactly the reason why an electron leans its magnetic moment to this specific angle when subjected to a B field, and homogeneous B field on the z-axis. So this is another very important physical explanation of why this intrinsic characteristics of the electron came to be, how it came to be, because these are embedded inside the complex charge flux manifold of the electron. These are all parameters. So here we calculate also the separate energies of this rotation and this rotation, and when we add them, when we superposition them, we get the exact figure of the energy of the electron, which is 0.511 mega electron volts. So in order to calculate the exact spin angular momentum and the radius generated by the revolution frequency, the FR, which it's not circular, we have calculated previously for the FS rotation, but the FR revolution, because it's a twisted ribbon, it's this twisted photon, this half spin twisted photon, we have to input the model in Wolfram Alpha simulation program. But before we do that, we have to parameterize all of its characteristics in polar coordinates. So the geometrical shape you can also find in Wolfram side is called horn torus, which are two circles, 2r diameters of each, and the height is r. It's so yes, it's 2r, and you have 4r here in this dimension, the x-axis, 2r in the y-axis, and 4r in the x-axis. But this model here, this geometrical shape will not do, because you remember there were studies and experimental studies that shows that the distribution of the charge of the electron via the interaction field it has, the electric fields, must be spherical, it's homogeneous. So the model must be sphere. So we had to modify this geometrical shape here to a horn spheroid, not a horn torus, a horn spheroid. And we have done this by introducing a deformation parameter, the parameter d here. So here are the polar coordinates of the whole model. We use the known functions, parametric equations of the horn torus, and modified them to the horn spheroid. We call this a horn spheroid. It's not more a horn torus, but it's more like a horn sphere. So it's a horn spheroid. And these are the final polar parametric equations we input in the simulation program. We had actually to modify this equation, the first equations, to input the parameter s. You remember this very important parameter is the ratio of fs rotation over fr rotation, angular velocity of spin over angular velocity of revolution of the ripple. So we have also to introduce this parameter here s. So these are the final parameters we use to input in the Wolfram Alpha simulation program. So our model had to obey, running it in the Wolfram alpha simulation, these two criteria, the angular momentum criteria of square root of 2, and also this equation here. So it is consistent with speed of light. It cannot exceed the speed of light. So although the S parameters and D to calculate them analytically, so that the resulting angle is the magic angle, yes, it's straightforward. Applying this to find an arbitrary combination of S and D, so that it's also light speed consistent, was a bit tricky. So we ran manually over 200 simulations, and from these 200 simulations, we picked 3 candidates, manifold candidates, which described and are consistent with our theory of our model. And this now we will present to you the Wolfram alpha simulation results of these 3 candidates, which are more we have used to demonstrate at best our model. So here in the first candidate is the perfect Horn sphere. We use the polar coordinates for sphere and added here this box function here, the parametric equations, to emulate this Horn tube here formation, which is in our proposed model. So the output was this actually candidate passed the 2 tests, and the revolution ratio, you remember this twisted photon, when you unfold it to a circular loop, what is the radius? It came up, we don't use here units for ease, it's 4.62, yes, which is the predicted value for the helical path, because the helical path, you see here the trajectory the simulation gave is an helical path of the ribbon, of the photon ribbon, and always the angular velocity you get more in a helix. You get it's acting like an angular velocity multiplier. So you get larger angular velocity with the same radius, which increases actually the spin angular momentum, the equivalent angular momentum. So this came here 4.62, and the predicted by theory is 4.72, which is very good. Yes, it's very good approximation. And for the predicted value from the circular path is 6.46. But you remember, we are not now interested on the effective circular path, because it's a twisted ribbon, so it has an helical formation. So we are not interested more in this figure here, not this. This is an effective circular value, but it's not the actual. Yes, because the energy ribbon is twisted inside the volume of the charge. So, and when you calculate now with Wolfram alpha the resulting angular velocity is 0.730, which is very good, because the theoretical value is in the x-axis, if you remember, is 0.707 times the reduced Planck constant, yes, which gives a theoretical value of 0.745, and our model, the simulated value was very close, 0.730. Also take into account here that we don't use the exact figures for example, for the speed of light. So we for example, put just instead of 0.299 times over 8 meters per second, we just put 3. We didn't put the exact. Sorry, we put the exact figures. You see, but only in accuracy of 2 digits. We didn't follow the whole digits accuracy. So this could be even closer. These 2 values, the theoretical and the simulated, could be even closer together. So this candidate here passed the 2 the two criteria, the light speed consistency and the angular momentum consistency criteria, which is demanded from our model. These two criteria to be fulfilled. The next candidate, we choose a candidate which failed the test, because most of these candidates failed the test, and only actually two, the previous one and the next one will be present, are passed the test. So this candidate, what we did, we took the Horn spheroid geometry we extrapolated previously, and we put the deformation factor at 2. Remember the deformation parameter? Yeah. So this model here totally failed. It produced an angular momentum of 0.593, whereas the actual predicted theoretical is 0.745. So it's totally lost the criterion, it fall off the angular momentum criterion of our analysis, and actually it failed also at the light speed criterion. So it produced 1.12 where it should be 1.41. So it totally missed both criterion, and therefore this model was rejected. This candidate here, this Horn spheroid square root 2. So now we're going to the next candidate, which actually is the best candidate, as we will describe later on, for our model. So this candidate is the golden mean Horn spheroid. This will be made apparent why we call this golden mean golden mean Horn spheroid candidate. So this gave here a radius for the revolution 3.86, but this is exact Compton radius. You remember, if you take the photon, the twisted photon, and fold it to a perfect circular loop, equivalently with the photon, the energy of the electron with the equivalent photon is the Compton wavelength, and gives exactly this radius. This is the reduced Compton wavelength. So this was very encouraging for this candidate, for this specific candidate. So it gave the exact reduced Compton wavelength, which is very consistent with our theory. Twisted loop, unfolded to a circular loop, perfect square loop, the radius must be 3.86. Of course, the volume, the radius of the volume occupies the ripple, because it's twisted, it's smaller. It's always as we have calculated, 3.344 times 10 power minus 13 meters. So the angular, the simulated angular momentum is 0.755, which is very close to the theoretical 0.745. So this candidate passed also the speed test. So this candidate is passed both tests, and with exact also the Compton wavelength, which is very encouraging. So in the next slide, we have now decided, here are the three candidates we have chosen over these 200 simulations. We used also deliberately also this candidate here, which just to show a candidate that failed the test. So we have the Horn sphere, the perfect Horn sphere, which, if you remember, was the first candidate we have shown, and this last candidate here, the Horn spheroid, the golden Horn spheroid, which now is the time why it's called the mean Horn spheroid, because it has the parameter d, believe it or not, is the golden ratio. We are not encouraging all this theory, philosophy about the golden ratio, because it's all over the nature. That's not absolutely correct. But in this case, we were astonished that the model worked so good for the golden ratio. So you cannot ignore that it is actually really a parameter which is embedded inside nature. So we regard as the best candidate for our model, which is consistent with our model, the golden Horn spheroid. Why? Because it exactly generates the Compton wavelength, and also it generates the exact frequency of when a positron electron pair annihilates. It produces two photons, and the frequency of these photons is 124.7 times 10 power of 18 hertz. Yeah, it's very large frequency. This was never actually experimentally verified, but it's theoretically there in the literature. And what I have just told you, when a positron and electron collide, annihilate, they produce two photons. Why two photons? Isn't that a strong, does this not infer that truly an electron is a twisted photon, a photon that is spinning and it's confined inside a volume of space? Why, when an electron and a positron annihilate, which actually the positron is an opposite charge electron, that's all, yeah, and chirality, opposite chirality. So why they should produce two photons? So this again infers strongly to our model that indeed the electron is a twisted half-spin photon, not spin one, which is a complete loop, but half-spin, a twisted loop, twisted photon that revolves and spins around an axis. So this two, the Compton wavelength, the reduced and the annihilation frequency here, are two criteria for choosing the golden horse spheroid as the best candidate for our model. Now we will present to you what we regard as the biggest contribution of our research, which is the explanation of the physical origin of the fine structure constant, this approximate 1 over 137 dimensionless characteristic, which characterizes the strength of the electromagnetic force. It's dimensionless because it has no units, has not volts, meters, amperes, or whatever. It's a ratio which is there in nature all over us. Without this fine structure constant, we will not exist, probably. Not probably, it's for sure, at least in the form our universe is now. But no one knows the physical origin of these parameters. And how they could know that if you regard the electron, which is the source of this parameter, of this fine structure constant, if you regard it as a dimensionless point, which has no volume in space. By giving, however, our model, by giving to this charge, to the electron, a specific radius, a morphology, a topology, and a specific magnetic flux energy flow, we can now decipher what exactly the physical origin of this fine structure constant is. And this was discovered by accident after we finished our model. We just said, let's now measure some geometrical analogies. And it turns out that the most basic geometrical proportionality constant of our model is the value of the fine structure constant, namely the diameter of the horn tube. You know this horn tube going straight from one pole to the other inside the manifold? The diameter or the radius over the radius of the whole charge of the electron, the whole charge, is exactly the ratio of the fine structure constant, the value of the fine structure constant, namely 1 over 137. So there you can find the analysis in section 3.3 of the published paper, and also in appendix 3 and 4, included in the supplementary material, which is the reference 28 inside the paper, and it's in Google Drive, in institutional Google Drive inside. So this was actually quite a find. We also devised here, using Mathematica, an equation which can help us to calculate exactly the radius here of the horn tube, giving the other geometrical characteristics of a fiber model. And in summary, here you have our manifold of the electron, the proposed model, the fiber model of the electron. Here is the magnetic moment, the magnetic dipole charge of the electron. The radius here of the horn tube, because it's a tube, it's not just a line, it's a tube of electromagnetic flux flowing, because these two are two dipole vortices, energy vortices combined together. You have this flux here, which represents the magnetic dipole charge of the electron. So the radius here, we actually analytically proved, this is also the one known in the literature. This also one astonishing fact, is the classical radius. The radius of the horn tube here is the given classical radius of our model, only because in our model everything is a bit shrinked, because the photon ribbon is twisted, it's not a perfect circular loop, so the volume is occupied but produces a smaller charge radius. Everything is smaller now, but it's analogous. So this here diameter is shrink, but also the diameter of the equator is also shrink analogous. So again, the fine structure constant comes up 1 over 137. So this is the horn tube, the classical radius, a bit shrink. The value in the report in the literature is 2.81 tenths power of minus 15, yes, meters. And this also is in the horn, they calculated exactly the radius extracted from our model. Yes, a bit smaller, but also smaller is now the Compton, the reduced Compton wave. Remember, the reduced Compton radius, which is this value, is 3.86 in the literature. Ours is, because everything is more compacted, is 3.34, and this here comes not to 81, is 2.44. But the ratio again, the ratio produces again this figure here, which is the fine structure constant. So the end result is that the fine structure constant is embedded inside the charge geometry of the electron, and is the ratio of these two radius. And here is also this is given in the literature. This is not a novel equation. Actually, in the literature, it's given the classical radius, which is Re over 2 pi, but this actually the Compton wavelength, the reduced is the Compton wavelength over 2 pi. So the reduced Compton wavelength is the Compton wavelength, this L without this dash here, over 2 pi. So it's actually the reduced Compton wavelength. So the fine structure constant is the classical radius over the Compton wavelength. Yes, and this however equation is a novel equation, because we used a different path to prove analytically our model. This is actually the ratio of the two magnetic flux in Weber units. This here is the magnetic flux flowing inside the horn tube, which represents the magnetic moment of the charge. It's the magnetic dipole charge. And this F, where F0, 4 times F0, where F0 is the quantum flux, it represents the charge here on the surface of the sphere. Yes, this here is novel equation, and this exactly results also in this ratio, the fine structure constant, which if physically, if you interpret this equation, what this equation says here, that the flux flowing inside the tube here is 137 times smaller than the flux on the surface of the sphere of the charge, which again is a derivative of this equation here, which compares the two radius of this radius. The the radius of this here and the radius of the whole electron charge actually controls the flow of flux here, the quantity of flux in here compared to the flux on the perimeter of the sphere. Yes, here we use also this this calculated novel equation we have imported in this equation here, which is also novel, which is gives the magnetic dipole charge in ampere meter units, and we have calculated is the electric charge times the speed of light. So this concludes our proposed model. Thank you very much for your patience listening to me. You can find because it's an open access publication, you can find this publication in a research case as well, in SSNR, and also in the whole repository. The official citation of this very important, we believe, publication is in the International Journal of Physical Research, published at the beginning of 2022. Again, thank you for your patience. Here is Emmanuel Markoulakis from the Hellenic Mediterranean University in Greece. Thank you.